Okay, 38. Now, a bullet of mass 10 gram is fired at 400. Okay. Okay, let's draw the scenario out. Now, it says that the bullet of mass fired, bullet then 400 meter per second, 然后 hit the box, right? Now, let's draw out. Okay, look, 你每次做这种 momentum 的 question 是先 draw out before and after, right? Because you have to know the momentum before and the momentum after. Now, the momentum before means that before 我开枪, right? It's like this. Okay, before and after. So what is the momentum before I open fire? There's no bullet coming out. The gun is still, right? Meaning that the momentum before is zero, right? No momentum. Now after 我开枪 bang, now bullet flying out. Now let's label all the given quantities first. Now the bullet is 10 gram and 400 meter per second moving to the right. Now after you open fire, this one, your gun will recoil what? Recoil at a velocity of 1. And the mass of your gun is 4 kg. Okay, now applying the principle conservation of momentum, meaning that momentum, total momentum before equals to after. Now total momentum before is 0, right? 0. So you put 0 equals to the total momentum after. So you have to figure out what is the total momentum after. Now first, because you have 因为你有不同的 velocity acting at different directions, meaning that you have to assign the direction. So here I assign taking the direction to the right as positive. Okay. For me, I want all the direction to the right is positive. To the left, negative. Now, let's work out the total momentum after. So it's M M1 V1 这个是 for the gun plus M2 V2. Okay, so it's 0 equals to 4 kg, and this one velocity, since it is acting to the left, then it is a negative, right? It is a negative. Okay, we don't put it yet because that is what we want to calculate. We put V1, right? So plus the mass of the bullet is 0.01 times the velocity is positive 400. Okay, so you worked out this one, you will get negative 4 equals to 4v1. Okay, you just times inside and then 然后这个你搬过去那边 you will get a negative, right? Negative 4 equals to 4v1. Now, when you calculate v1, v1 equals to negative 1, ms minus 1. Now notice that your final answer, you have a negative, means it is acting, moving to the left. To the left. So in physics, all the calculation, the sign is very important. Remember that. Okay, so that is how you find the V1, meaning that the gun recoil at a rate of 1 meter per second. Okay, so the answer would be B, minus 1. Okay, so the key for this question is because what is confusing is the total momentum before you fires the gun, right? Before fire is always 0. Okay. OK， 38，好了。OK， 39。 Okay, 39 is a 继续下去的那个 question. The bullet is fired into a block of wood of mass sun by juicer resting on smooth surface. Now pay attention to the keyword here, the smooth surface. Okay, if the bullet remains embedded in the wood, calculate the velocity. Okay, let's draw. Okay, the case before, the bullet is moving through the block, right? After the block and the bullet hits the block and it is stick inside, right? It stick inside. So that is the before and after. So before, what is the total momentum before? We know that according to the principle of momentum, right? Total before is total after. So you put m1 u1. U1 stands for the velocity before collision plus m2 u2 equals to m1 v1 plus m2 v2. Okay, so you take all the information from the previous 这个是300 joules/gram. Okay, so initially is the block moving? The block initially is not moving, it is at rest. Okay, meaning that u2 is 0. Okay, only the bullet is flying towards the block, so the block is at rest. But after the collision, the block is moving. Right now, the block is moving and is moving together with the bullet. Okay, so this is a type of what collision? This is a type of inelastic collision when the two objects moves together, right? Now, calculate what is the V here, V, the final V. Okay, since they are sharing the same V, so I can write the formula as m1 u1 plus m2 u2 equals to m1 plus m2, and they share the same V for inelastic. So m1, the mass of the bullet, same 0.01, velocity 400, plus, since the velocity of the block initially is 0, so this whole thing would be 0, right? 0 equals to, now after that you just take the sum of the mass, so 0.39 plus 0.01 V. Now you just want V. Okay, you will get V equals to 10 meter per second. Okay, and the answer is C, meaning that they will move at the final velocity, move at 10 meter per second. Right? This is the benefit of knowing the principle of conservation of momentum. Because given one object and another object, when they collide, okay, I can calculate what is the final velocity they are moving. Okay, based on if the initial velocity and mass are given. All right, question number 40. 诶，40有吗？40没有啊 ？OK， 不用紧，我们先看埋40。Also, I want to show you question 40. Also, very similar type of question. Okay. Question 40. A cannon fires a cannonball of mass 5.5 kg at 35 meter per second. The cannon recoils at 2.5. What is the mass of the cannon? Now, first draw out what is the scenario before and after. Okay, always remember this one. Now, means that before is before the cannon fires. Okay, this is your cannon. Before. Now, after is when it fires. Okay, now when it fires, my drawings. Okay, what is the mass of the cannon? A cannonball of mass 5.5 kg, 5.5 kg, and it fires a ball of, so this is moving at 35 meter per second. And the cannon recoils. You need to label, you need to label everything. Okay, so it's better to draw. 如果你画出来会比较清楚. So it's easy for you to label. So you label it recoils. So this is the recoil at V. I don't know the V. 不知道 V 是多少. So I just put V. And what is the mass of the cannonball? The cannonball, oh, the recoil speed is given. Is 2.5. This one is 2.5. 2.5 ms 减 E. Okay, what is the mass of the cannon? What is the mass of the cannon? The cannonball mass is 5.5 kg. So what is the mass of the cannon? How do we calculate it? Same method, total momentum before equals to after, right? So the momentum, total momentum before, what is the total momentum before? It's 0, right? Total momentum before 0. Why? Because it's not moving. No mass is moving. The cannon is at still. Okay, the cannonball is also at still 0. Total is 0. So you put 0 equals to after. So you count the momentum after, which is m1. Okay, 1 stands for the cannonball. This one, m1. We put it as m1, and this one is m2, right? So m1 v1 plus, this is the momentum of the cannon, plus the momentum of the ball, m2 v2. Okay, this is how you write the formula, right? So it's almost similar with the question 38, the gunfire. Also, total momentum before is 0, right? So equals the mass I want to find, I don't know. So V, I take what? I take negative because this V is different direction with this V. So always take right to as a positive and always take left as negative. So this one is negative 2.5 plus 5.5, okay, the cannonball mass times the velocity, so 35. So you just calculate, you get 2.5 m1 equals to 192.5, and m1 equals to 77 kg. B. So this is the mass of the cannon. Okay, 还有问题吗？ Okay, if no question, look at one more. I want to show you one more. The first page, 第六题，看全部人看第六题。Okay. Now, 第六题, it says that initially, you have two trolleys. Initially, the trolleys are put together. Okay, so this is before. The mass of the trolley, so first one is 1 kg, second one is 2 kg. Okay, and initially they both are at rest, right? So no momentum because zero velocity. Okay, now after that, it takes a hammer. It hammer this point, right? It hammer this one. What happens when it hammered this point? The two trolley will move outward in separate direction, meaning that after you hammer, trolley 1 moves to the left 1 kg, and trolley 2, it moves to the right. Okay, now it says that xy, it says that if trolley y moves a distance of 3 meters, so here, if it moves 3 meters, then what is the distance moved by trolley X? Okay, now this question is a little bit tricky, it's a little bit different, but the method is still there. It's still about conservation of momentum. Okay, so what we're going to do is we apply the total momentum before equals to after. So total momentum before is 0 because both trolley are not moving, right? And the total momentum after. Now, bear in mind that at the end of the question, we want to find the distance traveled. It's not the momentum, it's not the velocity, right? It's the distance. Now, how do we find it? How do we find the ratio? Okay, not ratio, the distance, okay? Time interval. Okay, 0. Okay, let's do it like this. Total momentum before is 0 and total momentum after is equals to how much? Let's work out the total momentum after, right? So you take the momentum of x, which is, I write, what is the symbol for momentum again? Momentum is p, right? Momentum symbol is p. So px. Now notice that x, after I hammer it, x moves to the left, means it is a negative momentum. Okay, momentum is also a vector quantity, meaning that it has direction. Okay, trolley moving to the left has negative momentum, and trolley moving to the right has a positive momentum. So this one is minus px and plus py. This is the total momentum of the two trolleys after collision. Okay, so negative px plus py. So before equals after plus py. Okay, now what you do here is you take this one, move it over there. Okay, so what will you get? You will get px, positive px equals to py. Now, this line means that the momentum of trolley gain, the momentum gained by trolley y, the momentum gained by trolley x is the same as the momentum gained by trolley y. This line over here, this line over here, it means that. Okay. both momentum is different, is the same. Now, from here, you expand the formula because I want to find the distance. I expand the formula. So momentum equals to mv. Okay, mv. Now, the mass for trolley X, is 1 kg. Mass for trolley Y is 2 kg. So you just write m for X and 2m for Y. Because it is 2 times of X. Okay, you write 2m. Okay, so mass times velocity. Velocity is, I write Vx for X and Vy. Right? Vx and Vy. So from here, you expand the formula for velocity. What is the formula for velocity? Velocity is equals to the distance divided by time. Okay, so m, distance of X divided by time, equals to 2m distance of Y divided by time. Okay, now from here, what do you do from here? You bring this one over there and bring this one over here. Means you exchange the places because we want to see the ratio, right? Meaning that m, wait, from here I write on top here. Meaning that you will get 1 over 2 equals to the distance of Y over the distance of X. If you rearrange the formula down here, okay, you'll get 1 over 2 because m and m will cancel out each other. OK， 你割掉把 m 割掉，然后把 t 割掉。为什么你可以这样子割掉呢？因为 m is the same, okay, because I already put 2m here, so m is the same. T is also the same. The time is the same, so I can just cut off. What is not the same is just the distance traveled, right? It's just the distance traveled. So from here I get this one. So now this is the last step. Okay, since I want to find the distance of X and given the distance of Y, so meaning that this one is 3 meters. So 1 over 2 equals to 3 over distance of X. Okay, so distance of X equals to 6 meters. So the answer is A. Okay, this one is number 6. Notice that whatever type of the question, we are still using the same principle to solve it. You just remember the formula. Total momentum before equals to after. Total momentum before can be 0, right? In cases like explosion, 就是那种 bomb explosion, before it explodes, the bomb is stand still there, right? Before it explodes means the momentum is 0, and after it explodes, it creates a momentum, okay, in different directions, right? For example, this one. Okay. Okay, I'm going to clear this whiteboard. If you haven't finished, let me know. I'm going to clear it. Okay, now let's do a short, excuse me. Okay, let's do a short recap on what we have learned last week. All right. Now, so far, momentum, principal conservation of momentum. Meaning that total, when two objects hit, the momentum of object A is transferred to object B, provided there is no external force. Okay, this is so far what we know about principal conservation of momentum. Okay, so as long as you have one object hitting another one, ball A hitting ball B, so the total momentum of ball A will be transferred into ball B. So there is no loss of momentum. Okay, provided 有条件啊，条件就是 it has to be on a smooth surface. Smooth surface. So remember that one. If it's not smooth, then the principal conservation of momentum does not work. Okay, not exist. Right. Okay. Now, and there are two types of collision. Let's recall. Elastic collision and inelastic collision. Now, what are the difference? The main difference. Elastic collision is when two objects hit, right? They bounce off each other. OK， 他们不会粘在一起的，他们一撞啊，他们就 bounce off， 就很像你打 baseball 这样 ，or you play basketball, right? Or it can be football. You kick the ball and then it bounce off. It won't connect with each other, right? So that is the elastic collision. Okay. Now most of the collision happen in our real life. It can be majority is elastic collision. Okay. Now in elastic collision, conversely, it is object will not separate. It will attach to each other. 就很像撞车这样咯。Okay, if you have one car hit another car, bang, it won't bounce off, right? Okay, 它们不会反弹 it won't bounce off each other. It is remain attached. Okay, remain together, attached, connected. Right, that is an example of elastic collision. Now, the main difference in terms of momentum between these two, okay, elastic collision momentum is conserved. This one is also momentum is conserved. Okay, now again, conserve, what does it mean by conserve? Conserve means no loss of momentum. Same with this one. This one also no loss of momentum. Okay. In other words, you can say that the total momentum before 等于 after. Same with this one. Total momentum before 等于 after. Okay, so regardless of the collision, 不管你是 elastic 或 inelastic 啦，你都可以 apply 那种 calculation for momentum because both cases momentum is still conserved. Okay, now provided there is no external force. Provided there is no external force. Okay, external force could be frictional force. One example is the very popular example is friction. Friction. Now, in real life, right? In real life, a ideal or perfect elastic collision does not exist. Why I say so? 为什么我这样讲 The perfect elastic or inelastic collision does not exist. Let's say we take a scenario 啦，如果你撞车是 inelastic collision 嘛，对不对？撞车我们可以讲if there's no external force, that means that the momentum of the first car, okay, the total momentum before collision, which is the momentum of the first car, is equal to the momentum of the second car, okay, because it transferred the momentum, right? Okay, but in real life, this case does not exist. Why? Because in real life, there is many external force, like friction, like heat, right? When the two cars collide, it produces frictional force, it produces heat, it produces loss of energy, meaning that the perfect inelastic collision does not exist in real world. So what you do in your calculation is just assumption. 意思说我们 assume there is no loss of energy, 我们 assume there's no loss of friction, okay? Then only we can do the calculation, okay? So meaning that in real life, your calculation does not work for the real life application. Okay, it just work for the books lah, the books. Okay, understand? Now, and another one, this one is about momentum. Another one is kinetic energy. So the main difference here is this one, the kinetic energy is conserved. Okay, no loss of kinetic energy. And this one, kinetic energy is not conserved. This is the only difference here. Okay, this one. Not conserved. In other words, I can say no loss of speed. Because kinetic energy is about speed, right? It's about speed. So this one is loss of speed. Okay, so I'm just giving you an overview, a big picture of what we have learned last week, okay, and a summary of it. Now, next one, we look at the application of conservation of momentum. Okay, there are many applications. For example, I talk a few examples. Like, okay, the first one, rocket. What is the thrust that the rocket used to propel itself to outer space? Okay, now if you look rocket, right, inside 它有两个 tank 的，第一个是 liquid hydrogen, and the second one is liquid oxygen. Okay, liquid hydrogen is actually 等一下，我这边想少过1分钟，所以我会再invite 你们的。我要 stop 这个先，I end this meeting and then I re-invite you back. Okay.